So again, hopefully you guys are in the right room. I know it's a little bit of 10 minutes late, but hopefully we'll make it worth it. Probably skip through a few things, but it's okay. There'll still be plenty of information. To start, who's familiar with embedded Linux specifically? Let's say with either developing or reverse engineering embedded devices? Show of hands. Awesome, that's great. Well, how about web? Anybody familiar with web application security or pen testing or? Okay, I would think. How about hardware? Anybody familiar with hardware hacking? A few. Okay, no problem. Again, so my name is Aaron. A few things are probably going to look a little bit different from what it looked on my computer, but that's fine. My Twitter handle here is scriptingxss. I'm from Los Angeles, so quite of a ways to get here, but definitely worth it. I've spoken at DEF CON IoT Village the last couple of years. Hopefully I'll be there again this year with some car hacking research that I just did. Fun stuff. If you guys are there, feel free to ping me. I've also spoken at DerbyCon, Hackfest, RSA, B-Sides, various B-Sides, and AppSec California, which is one of the conferences that we run from OWASP Los Angeles, representing right here. So we have our conference in the last week of January. So if it's cold over here, feel free to go across the pond to LA. We're right on the beach in Santa Monica. If you guys want to volunteer, I run the volunteers. Feel free. And like I said, I'm from Los Angeles, so I'm on the board for OWASP Los Angeles, as well as Cloud Security Alliance, Southern California. So even if you guys are in the area, you guys want to stop by, even give a talk, feel free again to ping me. I'm also on OWASP Slack, so first name, last name. I've also, in the past, I think last year, I was a technical editor for Practical Internet of Things book that's published by Packet Publishing. And currently, right now, I'm working on a pen testing IoT cookbook for Packet Publishing as well. So it'll be testing from hardware, from firmware, from mobile apps, web apps, and that should be out sometime in the summer. So pretty busy as of late. In the past as well, my past employer, I used to work for Balkan and Linksys on the Linksys side. For networking, so that's kind of where I've gotten to the whole IoT and embedded. And a lot of what I'm going to talk about is from my experience working for a manufacturer and also testing other manufacturers as well for peer research and talk. Sometimes I just buy products and just to hack and just to mess with them. Very fun. Some of the things I'll probably talk about today. Some of the things I've discovered. So let's get started. Embedded devices. If you don't know what that even means. And how they're even made, we're going to get to that. Generally, or loosely, embedded equals IoT. It's just now they're network connected. So you guys might be familiar. We have smart homes, and that's just one aspect of IoT. We have connected vehicles now, which have the hardware, which have the software, which have the wireless, which have Bluetooth, which have inputs and outputs. We have wearables. Wearables are really fun. I'll get to that in just a second. We have smart cities. A few smart cities in the world. We have smart buildings as well. Definitely, where the world is going, and it's kind of inevitable as well. So recently, last week, I just bought a few wearable medical devices for research. Over in the States, we have something called flexible spending accounts, so we could buy anything that's medical related. And I bought a couple or a few different devices that manage your health and report it to a doctor here. This is called CliniCloud. So I'll get to my research with that probably in another talk, but you basically send your info to a doctor and they can help you out, send recordings, you can imagine. But also pain relievers, they all have mobile apps, they're all Bluetooth. Definitely a playground for people like me and whoever else likes to get into wireless and hardware and software as far as firmware is concerned. So to briefly go over some of the threats that happened last year, if you're not familiar. Again, we'll start with medical just because it's kind of the topic right now with wearables. But we have insulin pumps that plenty of CVEs that were found, insulin pumps and clear text communications and privacy issues and sending data where it shouldn't be being sent to third parties without authorization. You have the consumer aspect where there's plenty of backdoors as well, and that still continues from last year to this year, meaning a backdoor account. Whether it's a root account, usually a root account, in any type of embedded device. Command injections are everywhere. Being able to arbitrarily inject shell commands, let's say via ping or any type of troubleshooting aspect of a device, a thermometer, even routers as well, pretty common. And then Mirai, we'll get into Mirai in just a second. Who's familiar with Mirai? Oh, not that much. Okay, well, we'll get to it in a second. Biggest thing that happened last year, huge. And connected vehicles, everywhere. I love connected vehicles. That's why I literally bought my vehicle 3 months ago, just so I can remotely unlock it, remotely start the car if I was able to, be able to chain different attacks. It's again like a playground as far as connected vehicles, and even the research last year with Tesla, various disclosed vulnerabilities with Tesla, and even Ford and other companies like that as well. As far as commercial, we know cameras, we know small business cameras, and that also contributed to Mirai. Ransomware, credit card machines. Who's heard of the hotel that was supposedly locked in? People who were staying there, but it was actually the credit card machine that was turned down, so it wasn't really everybody was locked in their room. But still, it's still ransomware. It's still affecting an embedded device. It's still a credit card machine. It still had firmware. Still relevant. But it's funny, we kind of get into these fear-mongering scenarios, people getting locked into, their hotel rooms, 500 people, whatever it may be. It's definitely real. The same with connected vehicles. When you have something pop up in your infotainment system that you need to pay however much Bitcoin in order for your car to stop, I'm pretty sure I'm going to stop. I don't know what's going to happen. Turn it off. But still, just the fear aspect of ransomware is another. It doesn't always have to be crypto. Just the fear aspect could be enough, unfortunately. And same thing with industrial control systems. Hard-coded passwords, meaning backdoors. Same problems throughout each of the different industries last year. And again, this year and the year before and the year prior. So you can kind of see the trend. Not much has changed. A lot of these vulnerabilities are simplistic in nature, which is great for us. Because there's simple patterns that we can look for as either someone who's an attacker or even from a developer standpoint. So again, Mirai. Mirai was huge. I'm not going to spend too much time on this, but I mean, it took down Netflix and SoundCloud and Etsy, our whole East Coast of internet back home in the States. And obviously, I wonder what the quantitative analysis came out for businesses being down for a few hours. So, and it's still there's different variants of Mirai, but they were saying it's this 400-pound hacker right here just pressing buttons. If you don't know the reference, I'm not going to go into it. But now we have different spins of Mirai. Ijami, BrickerBot. There's a new one that just came out a couple days ago, Perserai. And these are basically like vigilante botnets of Mirai, so trying to fix or shut down the services for, let's say, Telnet. And BrickerBot is basically bricking the device itself to take them off the internet. And you have Perserai, which is they're taking advantage of 0 days and doing the same thing, preventing other bots from getting access to that device. So it's kind of a free-for-all war. They're using Mirai as it's kind of a template for IoT botnets. And then it's only, like I said, a matter of time until we'll see something like ransomware affect all these devices. And again, if you reset those devices back to defaults, all they have to do is rerun their script and be like DJ Khaled, another one. Just keep grabbing them and grabbing them. And which what comes down to, Internet of Pwns. We have just everything, a lot of these devices are being publicly accessible just by their provider, by their installer. We have a lot of small businesses that are installing these IP cameras and these DVRs, which is the devices that were affected by Mirai. It's not necessarily routers themselves, not by far. It's mostly just IP cameras that are facing the internet as well as DVRs and various different kinds. But I mean, why that happens and how, well, first, the attackers find it by obtaining the firmware in some form, analyzing the firmware, extracting the file system, mounting the file system to analyze the file system contents and configuration, and almost like static analyze their code, because you can pretty much see it, all client-side code, the web server, configurations, any type of users that are configured, and also emulating the firmware for dynamic analysis and runtime analysis. So throwing something like a web scanner bypassing authorization using something like ZAP, runtime analysis using something like GDB. There's plenty of tools for that. Put a quick little link there if you guys want to grab that for research. I'll go ahead and make these slides available. I think I already sent a PDF as well, so no need to rush. Trying to stay on track here. But the main reason why and how these devices are created the way they are and why the vulnerabilities are the way they are in IoT and in embedded is because there's supply chain. You start with the PCB, then you have a board support package vendor like Broadcom, like Marvell, and then you have, and they have their own SDK. And then you have an ODM, original device manufacturer, who builds their SDK on top. And this is like Zhongmai Technologies, who were the ODM for all the Mirai devices. So they also sold them to resellers and different other manufacturers who put their name on it as the OEM. And now they have also a cloud service provider, which is someone like Amazon, someone like Azure, because all these DVRs now, all these IP cameras, even routers are all like SaaS platforms. Now you have a hybrid type of setup where you have the embedded device in your network, and you have basically a tunnel over to the vendor's cloud, and that opens up a port into your network without having to port forward. So now you have basically piercing NAT straight into your network, into your local LAN for access for video and sound is how these DVRs and IoT devices are being deployed using something like a stun server. Who's heard of stun before? Awesome. Well, it pierces NAT. Just know that you don't have to port forward. They think it's easy remote access, but easy remote access means you're opening up a port. If someone will be able to scan on that port, they can pierce right through your NAT just as well. So it's common for, like I said, voice and video. So voice over IP systems also use a similar tactic for real-time communication, RTC. So the supply chain is the reason why these devices are vulnerable, just because so many different hands, so many different codes are code bases are touching one single device, and then you also have the mobile apps, the web applications, you have the desktop, thick apps as well, not to mention the wireless, and then the firmware. Attack surface is huge, and all these are different teams and even farmed out to, third parties. The ODMs, again, are the main corporate. I put an arrow there because they're the main reason why IoT supply chain and the vulnerabilities are the way they are. It's not going to change. They're basically a dime a dozen, probably a 10-person team that are around for 3 to 5 years. So when you find a bug in a 5-year-old device, and you go back to the vendor and ask them to patch it, they have no way to go back to the ODM or go back to the supply chain and even back to the BSP, like Broadcom or something like that, to fix the driver and fix it all the way down to all their devices and patch it. So it's an interesting problem, and I'm not confident that it'll be fixed anytime soon unless there's some sort of incentive or closed type of environment similar to Apple, but again, that's kind of out there. So common operating systems that these embedded devices are running on are embedded Linux, variants of Android, really old kernels. I've seen a lot of new products on even Kickstarter that are based on 2.6 kernels. We're now up to 4+ Linux kernels. So there's obviously years, every year there's huge, you have Dirty Cow, a bunch of other, glibc vulnerabilities that get published, and these are all affected. You also have real-time operating systems, RTOS, and most of these, except free RTOS, are commercial. So except free RTOS, but you have VxWorks, you have to have licenses, QNX, which is BlackBerry, MQX is another flavor, Green Hills is just another vendor as well. Then you have the Windows embedded land, thumbs down, that's just me, but it's not as common. You'll see them more, let's say in point of sale devices I've seen, kiosks for the most part. And then Windows IoT Core, getting more common, but again, it's not as widely deployed as embedded Linux. So the basics of an embedded device or firmware, for example, in embedded Linux would have the flash contents. You have the kernel and the flash contents, the bootloader, the kernel, and the root file system. And there's variants of of different bootloaders, obviously kernel versions, and then file systems, different file systems as well. There's also compression, but that's compressing the kernel. So some best practices to secure embedded software. And this is mainly from a defensive point of view, from a developer point of view, and how these bugs get fixed. And we have, compliant examples and not compliant examples, but you have buffer and stack overflow protection. Very huge. You have a lot of heap overflows as well, which is also in the same bucket. Injection protections, like command injections, cross-site scripting, super common. You don't have like SQL injections in embedded devices, but if it's a SaaS or provider type of web application, you probably, it's possible. Firmware updates and cryptographic signatures to secure your firmware through an update process. Securing sensitive information, identity management, embedded framework and C-based toolchain hardening, so your libraries and how you build like your bootloader for your firmware device, or your embedded device, I'm sorry. Usage of debugging code and interfaces, so this would be dead code. We'll get into it in a second, but this will be dead code and possible backdoors. Transport layer security, TLS. I'm not saying SSL, I'm saying TLS. Usage of data collection and storage, privacy, how that data is being stored. Third-party coding components. That'll be keeping up to date your libraries and your frameworks that are being used. But kind of most importantly that we're going to add today is threat modeling. I think threat modeling is crucial in even, obviously any software, but any device, any type of architecture. And if they would even do basic threat modeling exercises, a lot of these vulnerabilities, wouldn't even come about or wouldn't even come to production and deployment. Said by Charlie Miller as well, just a couple days ago or last week, let's threat model before designing security systems, people, especially, DVRs and door locks, same thing. They're basics. If you were to ever to research a door lock or some sort of DVR or something like that, that's supposed to keep you secure from privacy or open doors, safety-wise, you'll find that the highest vulnerabilities or critical vulnerabilities are opening doors, and it's possible. I found plenty of them, and there's plenty of them out there that don't properly, you can tell they don't put their own due diligence to secure their devices in multiple ways. But threat modeling will help solve that. And so this is primarily based upon a project that I'm running here at OWASP called the Embedded Application Security Project. We have it here on Gitbook, so we want to keep it as updated as possible. So if those who rose their hand and they're familiar with embedded devices and software and firmware, we definitely would like feedback. And here's just our project page here. We just released our first version in March, and right now we targeted embedded Linux to start with, but we're gonna get on to RTOS and other Windows platforms as well. So keep an eye on that. By fall sometime, we'll have another version and even go in more depth and detail as far as the examples. And I would show you how it looked. I have my computer up here, but basically we do have, let's say, command injection non-compliant example. So why is vulnerable? And then we have literally in C. Then we have a compliant example, how to sanitize and validate input, and how it could be compliant, to put it in inside your firmware, or how to even avoid using system altogether, or using different patterns like number to strings. If there's a command being run, refer to a static file that has the command, almost like an ORM. If you guys are familiar with ORMs, similar to that. So buffer and stack overflow, same vulnerable C functions that we've known for years. Here's an example just to find command if you have the static code, the code in-house, or use safe equivalent functions, gets, fgets. They're not a catch-all. They're not gonna, keep you safe from everything. You still have to do your due diligence and verify the bounds and validate what's being run as far as buffer is concerned. You have to enable secure flags, and that'll be for whatever build system you're using, whether it be build root or Yocto. Those are the most common. And they're literally just menus to build your firmware automatically for you. And we'll go through an example. Oh, it's right here. So this is build root, and this is enabling stack protection here. Simple. I mean, just a checkbox. But it's just a matter of the developers and the project managers and program managers being aware how simple this could be to be enabled on their builds for firmware. And here's some examples of what not to use. STRL copy. Won't go through them in detail, but if you read through them, they're pretty funny. Injection prevention. Again, whitelist accepted commands. Avoid utilizing user data and operating system commands. Again, validate input, output, and code as well. And you could use something like comics to find these command injections. It's almost like a SQL map, but for command injection. Works pretty well. It also uses blind. You can find blind command injections. So this would be good if you want to sideload your own firmware through via command injection or get a shell on the device. And again, these are very, very common as far as command injections are concerned. Last year at DEF CON for IoT Village, it was based on command injection. Someone was able to upload their own firmware and sideload their firmware to a ransomware piece of firmware on a thermometer and spike up the temperature, 20 degrees. And if you have a smart lock locking someone in the house, yeah, it may sound like a joke, but it's possible, especially in the smart home arena. Here's an example of command injection here. And it's simple, literally just inputting shell commands. This is just basic ping, but obviously you can run a stager, meaning have something uploaded to the embedded device to pull down your whole payload. You can run it, let's say something like netcat, if you want to pull down netcat binary, and then run a command to call that netcat binary back to you for a remote shell. Very, very simple. As you can see, this is a real example, by the way, that's being exploited. It's part of one of the big botnets I was discussing, Perseride, the new one. And this is a C example of how code injection is filtered throughout the data flow of an application. It's basically just having dynamic code and not validating the input of what's being run for the any command here. So you can just add a user based upon the any command, because %s is usually just the input that the user's putting into the parameter, and it's not being sanitized at all. So I'm kind of skipping through this. We only have like 10 minutes here. So firmware updates, obviously very, very huge, a sore topic for many. Obviously you want to update over TLS. You want to have something like automatic or scheduled updates. But with the caveat, medical devices, you can't just update a device while it's being in use in someone's body. But you can force updates, the scheduled updates for medical devices, let's say, I don't know, at night, or I know scheduled updates don't work too well for Microsoft, but it's a different topic. But force updates when you have to, and it's high criticality vulnerabilities. And I've seen this in some of the DVRs that weren't affected by Mirai, which is good. They've also changed some other aspects of DVRs, and I'll get to that in a second, probably in the next couple slides here. But anti-downgrading, anti-rollback protections, so not being able to let consumers or anybody, commercial vendors or clients, whatever it may be, to install or flash firmware that is vulnerable version, for example, or require something like a password to download them. I've seen that done already, let's say with people like D-Link. Cryptographically sign and verify updates using, obviously hashes and whatnot. But also in your change logs include security-related vulnerabilities that have been fixed. This is often ignored, but we're definitely trying to push for this. And if you're using Yocto or Buildroot, they include their own libraries and they update their own libraries based, on their discretion. So it's important to check out or query which version, let's say, of UPnP library they're using. It could be a vulnerable one. And sometimes they also input any type of security-related CVEs that have been fixed that you could use, or that have been fixed that you can now implement into or deploy into your firmware image. And firmware versions clearly displayed. I think that's a big one as well, top corner somewhere. But definitely firmware updates, like I said, is pretty important and a hard thing to solve. Something with like GPG, for example, pulling down a kernel and verifying it, you have to have some sort of infrastructure. You have to know how to store your private key, how to deploy your public key, and when those expire as well, have a rollback. But this is just an example, and plenty of these examples are on the Git books for my project, for the project that I'm leading. So, but again, sore topic right here for verifying packages and even firmware updates. I think it's important, definitely important. So securing sensitive information, they're not hard code secrets, password, usernames, tokens, or similar variants. If you have a TPM or a secure element, or even trust zone, if it's an ARM architecture, utilize that as well. You definitely don't want to store secure information or sensitive information in clear text and unprotected storage as well, or flash, meaning EEPROM or other flash chips on a firmware device. And there's plenty out there. Even an SD card, for example, will be readable and writable. And this we know with Android devices. So very similar. And it's kind of common sense, but again, if someone did a basic threat model before these devices are being deployed or mass deployed, this wouldn't be the problem. We wouldn't have all these vulnerable devices within the internet, public facing especially. But an example of someone storing or hard coding, let's say a backdoor or an account would be here a D-Link router that accepted this user agent header here, and it would bypass authentication just by sending that user agent header. Very, very simple, but again, they probably think they use it for support or debugging purposes in production. But just recently, some people have been getting slapped in the hand, some vendors by FTC over in the States by not providing what they promise in their marketing, easy to secure, advanced network security, when they're hard coding login credentials and using default, guess by default, and broadcasting that information. So this is definitely new in our space as far as consumer devices, because typically, there isn't a regulation, there isn't a requirement, there isn't a certification for these consumer devices to follow. But for the FTC to slap people on the hand now, vendors such as D-Link, and we have others like ASUS, for example, they have to go through security measures now for a number of years to ensure they've performed their due diligence. And here's another backdoor count, and this one was for that Perserai botnet that's being used. This is one of the backdoor accounts that's being exploited in the wild as of right now. Again, for support purposes. I've been in these conversations. Why do we have to? Well, I know the reason why. There isn't a reason why. but let me quickly go through some of the last slides here as we're running out of time. So identity management, separation of users between internal and external, whether it's console, whether it's web, set keys in the URL. That's super huge and common in embedded devices. Even tokens, I see access tokens, I see long-lived tokens in the URL, and it can be replayed and are never expired. And this can be through the firmware, implemented through the firmware, but also reflects the mobile apps and the other web applications that are being used. Other advisements on sessions and cookies, secure attributes, things along those lines, randomize and invalidate these sessions as well, and put some sort of password, complex password, 32 if possible character, on UART, for example, to get access to the firmware. So running through here, embedded framework hardening, disable FTP, Telnet, the common ones, the ancient legacy services that are being exploited actively. There's no reason why. And again, it's just a drop-down menu for these vendors to unclick and enable even SSH and input a password. Not hard at all. Removing unused shell interpreters. Again, super common. I can go into an embedded device and see dash, ash, and bash all in one device, and obviously that expands the attack surface. And then iterative threat models. And again, I pointed out earlier how important that is. And again, there you go, bash, dash, and ZSH. Simple checkboxes with build root. And here's, not enabling FTP here. And then enabling like SSH, for example. Again, simple. not hard at all. And here we talk about backdoors and root privileges. And again, for debugging purposes, like I said, but there's plenty of people touching the code that will forget to take off their user that they created. No one's validating. They don't have a security team most often. Like I said, 10 people for these ODM software firms, and not one of them is focused on software security, which may or may not be a surprise. And it's so common. Like I said, what's being exploited right now is a backdoor, what I just showed earlier. And this is usually what they say, just unit tests and looks good to me. That's Stevie Wonder. Stevie Wonder's blind. But not looking. TLS, I don't have to beat this one down. You guys know TLS 1.2 or higher. Deprecate, the old Cypher suites and protocols as well. SSL, take it off altogether. And then how to validate TLS configurations and Cypher suites. I prefer Test SSL server. There's actually a new one that was published a few months ago, but it's based on C#. It's not a jar anymore. It has way more features. It can also export or output in JSON, so you can use it into a CI environment, for example. And again, no SSL is ever safe. It's never safe. Any type of software anymore. Won't get into that in detail, but an example, nmap command to find SSL v3 running on an embedded device in my network. Simple. Just going to fly by through this one right here. Privacy by design. Acquire only data that's required for the device functioning. Not gathering intel on all the devices that are being used in the network. Again, common, unfortunately. Try man in the middle in your router, and you'll be surprised what you find. And who's doing this as well as limit ad tracking for mobile is Android and iOS. You can reset your identifier. I think we're almost done here. And this is probably one of the crucial parts, is third-party code and components, and having a bill of materials and having accountability with vendors to have a security team on staff if these OEMs are partnering with the OEM, and use tools like Zap and these free tools like Lip Scanner, NSP. A lot of these embedded devices are now full JavaScript on the front end to take off the computational time on the firmware device itself. And utilize package managers, very common too. OPKJ, IPKG, RPM. If you guys use like a Wi-Fi pineapple, use something similar. But I mean, it's not too difficult. Obviously, it takes some testing to update packages. You don't have to reflash the whole firmware that people are always griping about. But again, Zap, NSP, and Linus to do OS hardening, find out what's as far as configurations are concerned, what needs to be worked on. And here's to find, this is using Lip Scanner. Lip Scanner here for a Yocto build. Based on your packages, it'll find CVEs, published CVEs. And this is the output here, the test cases. So just wrapping up here, again, threat modeling, super important, continuous, iterative, always update. Same thing with testing. And like I said, update. I can't tell you how many times from the consumer standpoint, when I was working over at Linksys, having auto updates for people who are using Linksys routers, it saved them from some sort of exploit or vulnerability. And if a vendor is listening or in here going to watch this, look up a disclosure policy, ISO 29147, to get involved in the community and be open to bug reporting and grow that culture. And there's some closing thoughts here. It's still a 0 day if they didn't update it. Let's be real. Let's keep breaking things, especially with us over in the US back in October. We got exempt from DMCA, so now we can research these devices as long as they're lawfully acquired within a controlled environment. And there's another third one, but I mean, this is huge for us when there wasn't anything like that before. So thank you, just finished. Thank you guys. No time for questions?
Unfortunately, we don't have much time for questions. Maybe you can take them outside.
Yeah, I'll be here, so feel free if you guys have any questions.
If you leave the room, don't forget to put it in the car. You don't have green, so blue for good, red for no good.
Blue, please.
I couldn't find green in Ireland, which is good. So thank you, Arne.
Thank you, everyone. Thanks for coming out.